Well, we know this very well that suppose we have this utility function UCL, okay, and we try to maximize this subject to given constraint, and we get an optimal value of C and L. Okay, L is this small L is leisure, as we have already told in the earlier recordings. Well, the point is that even if you want to minimize the expenditure, see, for example, in case if you maximize this utility subject to constraint, you will be getting these functions C star, L star. Okay, or if you want to minimize the expenditure in order to get a certain level of utility, say U naught, then also you will get the same answers. So that is a dual problem. And what is an expenditure here? See, C is the amount of the consumption which you're going to have at price. PC is normalized to 1. So PC into C is what you will have minus the amount of income. Okay, so this is the total expenditure which you're going to have. Now, if you want to minimize this expenditure in order to attain the certain level of utility U naught, you'll be getting the same answers. And this U naught is, say, UCL. This is the dual problem. Okay, the same duality kind of problem which we have already talked about in our earlier recordings. Fine. And if you look at it, then del E by del W is minus L. Okay. Now, since utility is being kept constant, and then you are trying to find out the optimal amount of the labor supply or anything, then this should be termed as the compensated labor supplied function. Okay, so because utility is being held constant, and we'll write this as, say, LC, just to show that this is the compensated part, which is dependent upon W, the wage rate, and the utility which you want to achieve. Fine, this is the some amount of utility which you want to achieve. Or you can say this is actually equal to L. In place of W, you can write, U, you can write this thing. Okay, this is the amount of expenditure which you have to make in order to attain this level of utility. Fine. But this is nothing but equal to N. So it is like this, that is Wn. Now, if you partially differentiate this, what you'll be getting is del LC by del W is equal to, just differentiating this, you'll be getting del L by del W into dW by dW, which is 1, plus del L by del E into del E by del W. But you have already seen that del E by del W is equal to minus L. Okay, so you can write this as del LC by del W is equal to del L by del W plus del L by del E into minus L. Well, del L by del C, in case if you look at it, del LC by del W, it is nothing but the amount of labor which is supplied at certain amount of wage rate at your wherever utility is being kept constant. So you can write this as like this also, when utility is being kept constant. So you can write this as now as del L by del W, U equals to U naught equals to del L by del W minus L del L by del E, or you can write this as del L by del W minus L del L by del N. So what you can write this as del L by del W is equal to del L by del W plus L into del L by del N. You've just taken this to the other side and you've got this. This is the Slutsky equation for labor supply functions. Okay, now this part is the substitution effect part. Okay, this part, the first part. Fine. So I can write this as changes in labor due to the changes in wages. It could be disaggregated into substitution effect and income effect. So substitution effect, in case if you look at substitution effect, which is del L by del W, U equals to U naught. Okay, this is positive. Well, in case if you remember, substitution effect in case of normal commodities, that is always negative, and that's true here also. Okay, del L by del W is positive. That would mean del small l by del W would be negative. Okay, so we are actually assuming that leisure is a normal commodity. Okay, and from that leisure we are deriving labor. You getting the point? So higher work is chosen at higher wages if utility is being kept constant. Fine. So in case if wages are higher, you'll be supplying more labor if utility is to be kept constant. Okay, del L by del W is positive. Note that it is not saying this is not wrong, because you might think that substitution effect is always negative. Fine. We're actually thinking in terms of labor, not the leisure. In case if we think in terms of leisure, this will come out to be negative. You getting the point? So this is the difference between the substitution effect of the labor supply and the substitution effect of the normal commodities. And the income effect is basically L into del L by del N. Well, you've already seen this, that del L by del N is negative. Okay, you've already proved this in the earlier recording. That is, as the non-labor income will increase, you'll be supplying less labor. Okay, you'll have more fun, you'll have more leisure. So del L by del N is negative. But at what's and you've already seen this, that this might work in the opposite direction. Okay, substitution and income effect, they work in the opposite direction. What exactly will be the sign of del L by del W? It depends. Okay, whether income effect dominates substitution effect, or whether income effect offsets some of the substitution effect, or what. So it depends, and this is working in the opposite direction. This is positive and this will be negative. Okay, L is positive, so this is, and del L by del N is negative. So substitution and income effect in this case, and income effect, they are working in opposite directions. Getting the point? So what way labor supply curve will look like, it depends on the strength of these substitution and income effects.